after year, the University of Colorado ranks among the nation's top research universities. So it's no surprise that here at CU, we are always aiming high. Now, speaking of shooting for the stars, we got one. A NASA astronaut is creating a buzz on campus.
Joe Tanner brings knowledge from industry that otherwise wouldn't be accessible. He's worked with NASA, he's worked with the big government contractors, and that has given us an opportunity to learn what it's like in the real world. And we're graduating soon, and we need to know these things.
I have an energy level that they enjoy, and I just look forward to what I can do for the university, because this is my school now. I didn't go here, but that doesn't mean anything. I'm a member of the CU family, and anything I can do to help their cause is something I really want to do.
Did you know that CU Boulder is the only institution of higher education in the world to build instruments for NASA? The $70 million Cosmic Origins Spectrograph is scheduled to take a trip straight to the Hubble Space Telescope in October of 2008. Now, the instrument will gather ultraviolet light from distant objects, and Tanner will monitor 5 spacewalks. This new high-tech piece of CU could bring a piece of ancient history to the forefront.
So the Cosmic Origins Spectrograph will be studying objects as nearby as moons and planets in our own solar system, all the way out to targets that are located on the other side of the universe, 13 billion light years away. And so we're extremely excited to be able to study all these different phases in the evolution of the universe and studying the different ways in which we have evolved to where we are now.
Now here's another blast from the past. When you peer up at the night sky, you're actually looking back in time. Now that's because the light from the stars takes years to reach us. In fact, astronomers measure the distance between stars in terms of light years, and that's the distance light travels in the course of the year. To break things down a bit, light travels at about 186,000 miles per second, multiplied by 60 seconds in a minute, times 60 minutes in an hour, times 24 hours in a day, times 365 days in a year. That's about 5,800,000. We'll say it's a really long way. To put it in a better perspective, a star that's 200 million light years away appears to us as it did 200 million years ago, or at the time dinosaurs ruled the earth. And we're going to be getting an unusual perspective on dinosaur days from a very different angle. Coming right out, I mean up. But as CU Science Updates' Adam McPherson shows us, you can just as easily step into the past by visiting the CU Natural Science Museum today.
Stepping into the past is as easy as taking a step into the CU Museum of Natural History. The fun and excitement begins with your very first step. Discover how people lived thousands of years ago in the anthropology section located downstairs. Let your mind wander as you explore just some of the nearly 1.5 million archaeological and ethnological objects housed at the museum. These artifacts come from all over the North American Southwest and Rocky Mountain Plains. Now, climbing the stairs only sends you further back in time. Enter a world when dinosaurs ruled not only the land, but the air and the water. The paleontology section houses fossils from nearly 45 different states and 80 countries, ranging from the smallest sea creatures to the rulers of the land. The museum also has fun hands-on activities for kids to let their imaginations go, well, wherever they want.
Now, whether your interests lie in the bones of dinosaurs or a few million years later with the Native Americans, the CU Museum has a little something for everyone. Now, the museum is open Monday through Friday from 9 to 5, Saturday 9 to 4, and Sunday from 10 to 4. The best part for CU students is it's completely free. Now, while the museum may be smaller in size, it definitely still holds some bigger attractions. For the CU Science Update, I'm Adam McPherson.
If you do have the opportunity to visit the museum, you might catch a glimpse of our next scientist at work. CU Science Update's Ryan Cusick is with a paleontologist who is getting the last word on dinosaurs. Ryan?
Thanks, Sadie. I'm here with Karen Chin, published author and paleontologist. Thanks for being here, Karen. How you doing?
It's my pleasure, thank you.
So I understand you study dinosaur poop. Is there a special word for that, or?
Yes, I study fossilized species.
Oh, okay.
And some of it is dinosaur, and some of it is from other ancient animals.
Oh, okay.
And it's an unusual thing to study, but it actually can tell you provide a lot of information.
Well, let's start at the beginning. How did you get involved with studying dung in the first place?
Well, I used to be a ranger naturalist for the Park Service, and I used to lead people on nature walks, and it's a lot more likely that you're going to find animal sign than the animals themselves. And then when I started working in paleontology, I was naturally drawn to animal sign in the ancient record.
Okay. So why dung as opposed to, say, bones or some more, commonplace piece of paleontology like Jurassic Park style,
Actually, you're right. Most people do
Yeah.
study what we call body fossils,
Okay.
which provide evidence for the structure of an animal. But trace fossils provide evidence for the activity of animals or organisms. And so they can tell us that footprints are trace fossils, bite marks are trace fossils, and coprolites or fossil feces are trace fossils too.
So you brought some stuff with you here. What do we have in front of us? It looks like a bunch of rocks to me, to be honest.
Actually, you're right. They're rocks because these guys are mineralized or lithified. That's why it's really easy to work on them. If I were working on archaeological samples, say from humans, they're actually not lithified, and they can reconstitute them, and they're not so pleasant to work on. But these are actually, it is a rock, and you can see this one actually is a piece of dinosaur dung.
Okay.
But just a piece, because you can imagine that the original piece was probably on the order of about 6 quarts in volume.
Oh, wow.
And when they're exposed to weathering, they naturally just break apart. But a piece is just as good, and this one has several interesting features. You can see a burrow through here. That was probably an animal like a dung beetle that was actually feeding on the dung. And this particular specimen is filled with rotting wood, or it's filled with wood, and this tells us that these particular dinosaurs actually fed on rotting wood, which is not what we'd expect. We expect them always to be feeding on green stuff, but we're learning more about the fact that these animals weren't exactly like the animals we have today.
So can you determine, say, what type of dinosaur it is, or animal for that matter, from the piece of coprolite? Is that the right term?
Yes.
Yeah.
It is very difficult to determine, as I like to say, who dung it.
Okay, nice.
Because the coprolite may be here and the body fossil will be long gone. It'll be far away. So we have to see what other fossils are found in the same sediments. In this particular case, there is a dinosaur called a Maiasaura that is large enough to have produced it. We know it was a plant eater from the teeth, so that is the most likely candidate. But every time we say that this is a coprolite, we say it was probably produced by Maiasaura because we didn't find it in the gut of the animal.
So when you're in the field, how difficult is it to spot that? If you're just walking on a trail, how can you tell you're looking at a piece of dung as opposed to just a standard stone, like off the trail or something?
It's really difficult. It's really difficult. In fact, sometimes, I'll show you here, sometimes rocks can look very much like coprolites themselves. They have a similar shape and they can have a similar color. And I've looked at a lot of these and I have a good idea what to look for. But there are specimens that people send me that even I can't tell whether it's a coprolite even after I do some chemical analyses.
I understand you wrote a children's book, Dino Dung, I believe was the title. How do kids react when they tell you that when they find out you study dinosaur poop? I mean, does that like spur their interest, or how does that work?
It's actually, I like to emphasize that this is a very serious science. It tells us things about the fossil record that we cannot learn from body fossils like bones. But it is an excellent way to get people who are not so interested in science. And that's why I think, yes, people, including young people or little people, they giggle when they find out that I study fossil feces.
Yeah.
But then when they learn why and the scientific method we apply to learning more about these, they begin to understand why it's important and how science works. I had one child write me through her dad. I think she was about 4. So her dad wrote the email and said that she liked, her dad read to her every night, and her favorite book was Dino Dung. So it made me feel good.
That's a good sign, yeah.
Yes.
If people enjoy the book. So like, what are you working on right now? Are you studying anything in particular right now, or?
Well, I've got lots of projects going on. One is working on ancient feces from the Arctic that are the same age as the dinosaurs, but they're in a marine environment. So big fish, marine reptiles, and the thing that's interesting about...
Wasn't the Arctic frozen back then?
No, that's the interesting thing. It was much warmer.
Oh, really?
So it kind of gives us a window on an environment that we're kind of heading to, a warmer Arctic environment. And I'm also working on other dinosaur coprolites.
Oh, very nice. So what would you say is the most interesting thing you've ever found in the field? Like what's your coup de grace in terms of coprolites?
Oh, there's several projects I like. Let me give you just a couple. One, I was working on some fossilized coprolite, or some fossilized feces from a carnivorous dinosaur, a relative of T-Rex, an older relative, and we found fossilized muscle tissue in it, fossilized meat. So that told us two things. It told us not only did the meat pass quickly through the digestive tract, but it was fossilized probably within a matter of weeks. So that was really exciting. And then this one that I just mentioned, the fact that we could find dinosaurs feeding on rotting wood when modern big herbivores like elephants and rhinos, that's a different diet from them. But you think about the fact that modern mega herbivores, as we call them, they have milk that they can feed to their young. The mega herbivores of the dinosaurs were more like birds, and they could not feed their young milk. So the other thing other study that I thought was a lot of fun was working on these specimens that had so much wood in them. We don't find modern mega herbivores eating lots of wood. So this reminds us that the dinosaurs had different biology than our modern mega herbivores like elephants, elephants and rhinos.
So we spoke earlier. You wrote a children's book that we hit on earlier. We actually talked to a few kids about what they thought of the book, and here's what they had to say.
Hi, Ryan. Ew. It's kind of weird to read a book about dinosaur dung, but you can learn a lot from old poo. Fossil feces can tell stories that bones can't tell by themselves. And look at these cool pictures. Fossil dung detective Karen Chin definitely makes it easier for kids to understand the science of paleontology. I interviewed a couple of my friends who read the book Dino Dung, and here's what they have to say.
I think it's cool how you can tell about what kind of food a dinosaur ate by like the plants and stuff inside its poo, and that not only do you learn about the dinosaur, but you learn about the environment 1 million years ago.
I thought it was really unique that a piece of dung has to be in exactly the right place, in exactly the right conditions for it to be preserved. And if all those conditions are correct, then it can be fossilized for over millions of years. And the paleontologists can dig it up and use it as another piece in their archaeological puzzle.
There you go, Ryan. That's the scoop on ancient poop. I'm Michelle Schrader reporting. Bye.
Thanks, Michelle. So, yeah, what do you think about those reactions? I mean, they're learning a lot, obviously, but how does that make you feel?
I'm glad to know that kids are learning from my book. I teach here at the university, but I realize that the book has sold about, I think, 17,000 copies, and I realize I've probably reached a lot more people, little people, teaching them about science through this book than through the classes I teach here.
What's the difference between showing your science in to a college setting as opposed to like explaining it to children?
Oh, just the degree of difficulty, the depth, and the background.
Oh, yeah. Anything else you'd like to hit on before we wrap it up?
Yes, I would just like to point out that sometimes when people learn that I study fossil feces, they think, oh, how cute. And yes, it is cute and it is amusing, but I like to point out that this is a very serious science, and we have learned a lot about ancient ecosystems that we would not know from studying other fossils. So It is unusual, but it's serious science.
Thank you so much, Karen, for your time. I guess it all comes out in the end, if you will. Thanks so much for your time. Back to you, Sadie.
Thank you, Ryan, and thank you for joining us for CU Science Update. See you right back here next time.